Hi everyone, my name is Ria, currently pursuing computer science engineering at Aadhaar Institute of Technology and presently doing data center engineering internship at 3QI2605. Here I'm going to explain about the project high availability on LAN network. The high availability ensures continuous network operations, reduce downtime during device or the link failure, achieved using redundancy like multiple routers and paths, important for the reliable and uninterrupted communications, automatically switches to the backup systems during failures. The problem statement. A single point of failure in the network causes complete downtime. No backup paths lead to the loss of communication. The router fails, disconnects the entire network. Manual IP is inefficient and irrelevant. Need for the automatic failure and the reliable network design. Duties. Implement high availability in LAN network. Provide gateway redundancy using HSRP. Ensures continuous IP allocation using DHCP high availability. Create multiple paths for failure. Improve network reliability and fault tolerance. The device used in my design is uh, routers, switches, PCs, and other cables. The design I have used is multiple routers connected using crosslinks, which is in a star topology, and redundant paths created over failovers, which helps to have created multiple paths for the same router. If the router fails, if one of the path fails, the other can take over. The messages used to connect the NPCs. Also, the switches are connected in a mesh topology, where one uh, path fails, the other can take over and make the communication available. Additional routers are added to the improve availability. Design ensure no single point of failure. This is the design where switches are connected in a mesh topology. Uh, if single pass fails, the other can take over. Also, the routers are connected in a star topology. Where one path fails, the other can take over. Also, I have implemented one more router as a backup for more. If that one router got fails, the other can take over the communication. The IP address I have used in LAN 1 is 90.168.0, which is /ND4 in the socket mask, and the gateway is 1.1. For LAN 2 also 2.0 network gain open mask, also 2.1 is the gateway. For WAN, I have used 7.0/30 subnet mask, which is .25, 255.255.255.25. Redesigned for IPs. The network has four IPs, one network ID, one broadcast ID, and two usable IPs. Then I used HSRP, and the IP address is 192.168.1.1 for LAN 1. For LAN 2, I used 2.1. Also, I have created DHCP. The DHCP IP address range are from 1.3 to 1.254, and the gateway I have assigned with DHCP is 1.1. For LAN 1, for LAN 2, I used 2.3 to 2.254. Also, same subnet mask. Also, the gateway is 2.1. Then HSRP and DHCP. The HSRP is all standard by protocol. It provides gateway redundancy. Like if one router is it makes one router active, another in a standby. Also, I've created virtual gateway IP for the end devices. Only one only one gateway can be assigned. Also, if there is a, I used two routers for the for the high availability. So there will be two gateways. So we need to use a one virtual gateway for both of the routers for gateway. I have used the HSRP protocol, which allows you to create a virtual IP, it can act as a gateway. Then DHCP dynamic host configuration protocol. The DHCP has configured on both routers on the network. The DHCP allows to DHCP, DHCP automatically assign IPs to the PCs without any manual configuration on devices. Also, the DHCP configure on multiple routers provide high availability. I use uh, the DHCP. I have used the DHCP full. The network is 1.0. Default router is 1.1. Also, I included the IPs like 1.2, 1.1, 1.2, 1.3. These are using IPs as 1.1, 1.3 is the interface of the two routers in the same network. Also, 1.1 is the HSRP, which is the virtual IP. It acts as the gateway. Then here is the HSRP where I have made 192.168.1 as a virtual IP. Also, I have given the priority as 110, which makes this router more like a root. Even though if the router fails and come back to the line, it will uh, take over the main. Mm, Same also I have configured in the router tools. Then the testing and verification are pinged between the PCs. This is the gateway which I assigned for this PC. Now I'll put in 3.1. This is the second device, which is this is the device of the second network. Like this is the 2.131, and here is the ping verification. Also, I have checked the DHCP failure, and now the IPs are assigned by this router. So I'll make the interface down. Even though this even though this path is failed or the router is failed, the other router can take over and assign the IPs. If the DHCP got allocated, the IP got allocated. So even though the one router fails, the other can take over and make the communication stable. Mm, DHCP failure also shut down the router. Have done. Uh, IoT is fully implemented in the LAN network. HSRP ensures that the gateway failures. Also, the HCP provide high availability when the one router fails. You provide IPs to the end devices. Also, the switches are counted in mesh. When the one path fails, the one path fails, the other will take over the network or the communication. Here also same thing. I have used the RIP protocol for the routing, where it uh, automatically find the other networks which is connected to the network. also are used from. This is my document from board. The project planning has been done in March 45 and network topology design from 67. The DHCP configuration are done from 9 to 10 and the device configuration and testing in 11 to 13. And when I try to do some improvement in my project, it was 13 to 14 by adding routers as extra routers in pan. The pan actually added in 15 to 16. Mm, Thank you.